Hello and welcome. This is the harder Edexcel C3 papers. This is a G4 paper, so please do check that out on physicsandmathspaper.com. As I said, if the link's not in the description. Okay, so this is question 5. This question is again from June 2013. Okay, so we've got x is equal to sec squared 3y. And y is between 0 and pi and 6, but as I said, for the first part that's not really that relevant. Okay, so the first thing we're asked to do is find dx dy in terms of y. Okay, so all we're asked to do is find the gradient equation, which doesn't sound too difficult, and truth be told, it isn't that difficult. However, there's one thing that you need to consider. Naturally, when we'd have, if this was, because this is sec squared 3y, and obviously sec is 1 over x, 1 over cos x, so therefore naturally sec squared x, or in this case sec squared 3y, is 1 over cos squared 3y. Okay, but if you were to do that, you wouldn't be able to do anything with that. Okay, you might do, oh, okay, well I know that cos squared x, and you would use the cos 2x formula and rearrange that, okay? But that wouldn't help you a great deal. And really, there's nothing else that we can do with that. I mean, possibly we could change it into a tan squared x, but then we'd have exactly the same problem, okay? Just with a different trig function that we couldn't cancel down. So the best way to think of this is, because we know how to integrate sec x, there's a formula in the formula book we have for integrating sec x, or in this case it would be sec 3y in that case. But what we've got to consider here is the fact that sec 3y, okay, sec squared 3y, sorry, is the same as saying sec 3y all squared. Okay, because you don't square what's inside the sec. Okay, so if you integrate that all squared, it's a lot easier than integrating that, but they both mean the same thing. Okay, so if we were to do that, integrate the differentiation. Okay, we'd use the bracket rule of differentiation. Okay, so what you would do is therefore you do dy dx equals 2 times brackets, you reduce the power sec 3y, and then you do the differential of sec 3y, which is 3 sec 3y times tan 3y. Okay, and obviously because we've got a common number there, it's going to be 6 sec squared 3y tan 3y, and that is equal to dy dx. Okay, and it will just wants dx dy. We can know about it today. It's equal to dx dy. Okay, and that's all it wanted, dx dy in terms of y, and that's exactly what we've got. So even though you would naturally want to take that further, that is going to occur in part B. And part B wants us to show that dy dx is equal to 1 over 6x brackets x take 1 to the power of a half, or in other words 1 over 6x times the square root of x take 1. Now, if you were completely unsure of what to do here, which obviously you shouldn't be, you could always work back from this by inputting x to be sec squared 3y and working backwards and integrating it, solving a differential equation if you were you would have done C4 by the end of the A level, hopefully. Okay, but assuming that obviously you wouldn't do that, and you would think, okay, well what can we do here? Well, obviously the first thing that you should spot is that x is sec squared 3y, and we've got a sec squared 3y in here. So the first thing we can do straight away, now don't bother that we're not changing the x dy to dy dx straight away, it doesn't really matter. Okay, so that's 6x, but then we're 6x times tan 3y. And obviously we want this tan 3y in terms of x, but we know x is only x equals sec squared 3y, so we need an equation which links sec and tan. In other words, the only equation that does that, or comes close to doing that, is the good old equation, tan squared y, tan squared x plus 1 is equal to sec squared x. Okay, and you can obviously replace the x with 3y, which obviously would be more relevant in this case. Alright, but we don't want, and obviously you would rearrange that to get tan squared y and tan squared 3y on its own. So tan squared 3y would be equal to sec squared 3y take 1. But we don't want tan squared, we want tan 3y. So it is as easy as simply square rooting. Okay, so therefore the tan of 3y, which is what we want, is equal to the square root of sec squared 3y take 1. And obviously that is all the same as writing sec squared 3y take 1 all to the power of a half. Okay, and we know that x is equal to sec squared 3y, which is what we've got over here. Okay, so we just do therefore tan of 3y is equal to brackets x take 1 all to the power of a half. Okay, and because we know that we want to get rid of tan 3y, and we've got tan 3y is equal to x take 1 to the power of a half, we simply sub this in to our current equation. Okay, so therefore dy dx is equal to 6x brackets x take 1 to the power of a half. But remember, that is what dx dy is, and we want dy dx. Okay, and dy dx is 1 over dx dy, so we do the reciprocal of either side. So therefore we get dy dx is equal to 1 over 6x brackets x take 1 all to the power of a half, and that gives you your end answer. Okay, so that is the end to part B. Okay, so as I said, hopefully that was made fairly simple to you. But really, as I said, it was still a bit of a testing question. Alright, so obviously we're not over yet. Now we need to find d squared y dx over dx squared. In other words, we've got to find the differential of that, which is going to be a bit tricky. But there's a couple of ways that we can go about this, so don't get too worked up just yet, because there's still ways that we can get around this. Now what I'm going to do is work out, so just double check what I'm going to do first before I actually do it and get it wrong, which is obviously quite likely. Okay, let me just, obviously just another one as my followers just saying I need some help. Well, I'm just trying to find where, just double my answers. Right, okay. The reason, it's obviously asked us to do this for a reason. This next part is a little bit more testing, maybe even more testing than part B, okay? It wouldn't have asked us to convert it into Cartesian form, which is what that is. Pretty much all that means is just in terms of x and y, if we didn't have to do anything with it, okay? Right. So imagine the best thing to do with this, because we've got to find the differential of the differential. The way that I thought about this, now obviously this is not the way I wrote it down in my answer, because obviously this would be wrong. I'd now be changing the answer if I were to write this. But you think of this dy dx, or what we've now found to be dy dx, okay? And you can think of it as your original equation for y. If this was your original equation for y, because essentially what we're doing now is finding the differential of this, so it doesn't really matter that it says dy dx. Obviously for our end answer it does, but it might put you off that we've got dy dx there. So if you imagine that's y, just be crazy kids, how would you differentiate that? Well, it's a fraction. Yes, there is a product on the bottom, but we can deal with that later. Don't be throwing your maths book up and down and whacking your neighbour on the head going, "Ew, I didn't sign up for this," and he's like, "Oh, don't hit me, I didn't take maths," and you're like, "Well, you're going to pay for it." Anyway, so, you know, as long as that doesn't happen, it's all good. Okay, so, as I said, I know we've got a product on the bottom. I'm not really bothered about that just yet. This doesn't affect it. And I know we've got one on the top and one will differentiate to give 0. But again, I'm not bothered about that, because I'm not bothered. So it can't be good. Typical living in Gatley, that. Okay, so dy dx. Well, obviously this is the use of the quotient rule. Okay, so obviously if you can imagine that as a y equation, you're going to differentiate that, you'd say that was equal to u over v. So what we're going to do is work out what u dash v dashed is. Okay, so somewhere at the side you put u, well that's equal to 1, and u dashed, I know that's equal to 0, but don't be so put off by that, okay? V, well that's obviously equal to 6x times x take 1 all to the power of a half. Now this is where it gets a little bit more tricky. You have to imagine this as another separate differentiation product. It's another product rule inside a product, inside a quotient rule. This is why this part is, I think, particularly difficult. Okay, so actually I'm going to go one step further and rub this crud off to the side. Okay. So we need to take up this now as another rule. Okay. So let's assume, now I originally assumed that we had classed all this as y, but I'm now going to class this as y again. But I'm going to call this y subscript 2, just so it's easy to understand. We say this equation, y subscript 2, is equal to 6x times x take 1 all to the power of a half. And you can imagine this now as an easy product rule. Okay, so if we let u is equal to 6x, therefore u dashed is equal to 6. V is x take 1 to the power of a half. Don't know why my voice went there. Okay, and we need to differentiate x take 1 to the power of a half. And because it's a bracket, we can use the bracket rule. I hope that made sense. Okay, so it's a half times x take 1 to the power now of negative a half times the differential of x take 1, which is just 1. So we can just leave it as a half of x take 1 to the power of negative a half. Or in other words, you could rewrite that as 1 over 2x take 1 to the power of a half. Okay? Now what we do is we sub it in. Now, as I said, you could leave that as the power of negative half. I'd just write it in, just in case, depending on which one we're going to use. So it's a half times x take 1 to the power of negative half. Or it's just 1 over 2 x take 1 to the power of negative half. Okay? So, we write that as v dashed. I'm going to write this one over here. So, v dashed is a half of x take 1 to the power of negative a half. Okay? So what we're going to do is now apply this to the standard quotient rule that we would be used to. Okay, so instead of labeling this dy dx, I'm going to leave it dy squared dx squared, which obviously just stands for the second differential. Okay, so what we're going to do here is simply is equal to v u dashed. Okay, so it's 6x brackets x take 1 to the power of a half times u dashed, which we know is 0, okay, so it's times 0. You could square bracket that off, and I would do. Take, well, it's now take uv dashed, so it's 1 times. Now you can obviously leave the 1 out if you wanted to, but I wouldn't recommend it because you're likely to make a mistake. Okay. I'll try doing this from down here actually. That's not going to work. Okay, so it's 1 take uv dash. Sorry. So v dash we said is this a half x take 1 to the power of negative a half. Okay, and then you would close brackets and end the square brackets, and that's all over v squared. Okay, v being 6x x take 1 to the power of a half, and you square that on the bottom. Okay, now obviously that's going to come to obviously that's going to come to 0. So it's ooh. Obviously I've done that right. not right at all. Brilliant. I'm not sure exactly where I got up to with that, but basically what we are now doing is we've now got to apply the products rule to this y subscript 2. Okay, so we've got what v dashed is, u dashed, u and v. So we just apply it to the differential for the products rule is uv dashed plus vu dashed, or the other way around, doesn't really matter. Okay, the one I'm going to start with is vu dashed. Okay, so it's 6 times x take 1 to the power of a half. Okay, so that's 6 brackets x take 1 to the power of a half plus uv dashed. Okay, so it's 6x times a half brackets x take 1 to the power of negative a half. Okay, so we simplify that down. Obviously the 6 brackets x take 1 to the power of a half stays as it is, and then we get plus 3x brackets x take 1 to the power of negative a half. Okay, so as you can see, this is now our answer for v dashed. Yeah, because this y subscript 2, remember, was the same as saying v. Okay, so to work out the differential of y2 is working out v dashed. Okay, so that's what v dashed equals. So let's just put that as equal to v dashed. So now we just apply the standard quotient rule, which says vu dashed, okay, yeah, which is just this times 0, which is just going to be 0. Okay, so d squared y over dx squared, in other words, the second differential, is equal to 0. Take u v dashed, okay, and it's just 1 take times all of that. Okay, so it's just 1 take v dashed. Sorry, 1 times v dashed, which is just v dashed. Okay, so it's 0 take 6 brackets x take 1 to the power of a half plus 3x brackets x take 1 to the power of negative a half. Okay, and so all over v squared, which is 6x x take 1 to the half all squared. So you square each term individually on the bottom. Okay, so if you were to do that, obviously this would, if you were to take away 6x to the power of a half, that would be negative 6x to the power of a half, and then you take away positive 3x brackets x take 1 to the power of negative a half, that would be take 3x brackets x that take 1 to the power all to the power of negative a half. Okay, and when you square all of this on the bottom, we square each term individually. So the first term becomes 36x squared. Okay, and when you square x take 1 to the square root with 5 and a half, that just becomes x take 1. Okay, so that is therefore your end answer to that question. Let me just double check that, because obviously, you know, with my dubious skills, you can never be too sure. You do that? Sorry, that's not that is the answer, but it's a simplified answer. I do apologise. Can you do with that? Just trying to explain this. Okay, well, you have to remember this is now to the power of 1, and what we do here is, that is the power of a half, isn't it? Yep. Yeah. Sweet, isn't it? Just trying to, sorry, I know this isn't the smoothest of explanations, but what are you going to do about it? Absolutely nothing. when we divide by power, okay, so we divide x squared by x cubed, we subtract the powers. The same kind of thing happens here, okay? But obviously that's negative, so we subtract, negative take away 1, which obviously leaves, negative a half take away 1, which obviously leaves 3 over 2 on the bottom, which cancels out with this a half, okay? So essentially what happens is we're left with 6 take 9x over 36x squared, brackets x take 1 to the power of 3 over 2. We can cancel that down to, I do apologise, it's the smoothest of answers, 2 take 3x over 12x squared, brackets x take 1 to the power of 3 over 2. So we do apologise if that's not been the smoothest of explanations. Okay, I can quite clearly see that hasn't been, but I'll redo it again if it's that bad. But if you've got any questions, and I'm assuming you probably do have with my poor explanation there, I will try and talk you through it or do another video on that particular question, because I did make a little bit of a hash of it, and yeah, I'm quite sure I can do a little bit of a better job. But obviously that requires a bit more work, and we don't have time for that. Anyway, so that's the end of question number 5. We're going to move on to question 6, which is, you'll be glad to hear, a little bit easier. Okay, so thanks for watching. That's the end of question 5. As I said, we'll see you in question 6, hopefully.